So I thought I'd record this video in case somebody's got a graphing calculator to do these chi-square goodness of fit tests, and you need a newer model. TI-83 doesn't do goodness of fit tests. I think some of the earlier models of TI-84 pluses don't either, but they have for the last 10 years. And then of course these new CE models, they aren't that new now either. They do a goodness of fit test. Now, there's two kinds of goodness of fit tests. I'm sure you've read the textbook and everything or watched some videos. And this is one we're doing multiple choice test here. Let me get a pointer going here. So see if the multiple choices are evenly distributed. So the probability of any one choice is equal, you know? So what you do with your calculator is you do stat edit, and you've got these stat lists coming on, and I'm just going to clear these out of here since I don't need this data. And if you're new to graphing calculators, you have one. The way you clear a list is hit your up arrow so that the list is there, and then you just press clear and then enter. I mean, if you accidentally hit the up arrow and press delete, you'll think you've deleted the list. In fact, let's go through and delete them all. No, it doesn't matter. How do you get those back? I remember when I first started using them, that was a problem. So quit this screen. You're going to do stat 5, see setup editor. And if you just press enter, it'll bring back all your other lists. You can do a lot of other things with these things, but it's kind of passe now. And if you want to learn how to set up other lists, I certainly can show you. Let's go back here, edit, and see all my lists are back. I'm just going to type in those observed values. 32 and 30. And then because these every choice is equally likely, all we got to do is divide, because there's 4 choices. We got 100. You see in the problem, 100. Well, if we didn't have 100, you just divide it by 4 because there's 4 groups, and so it's nice and easy. This one, it's okay to have a decimal in the expected value, but in this case, they're all the same. I'm going to do another one where they're not all the same, and I'll show you how to use a calculator for that too without a lot of work. So I've got my observed in L1, I got my expected in L2, and what I'm trying to say, my HO is these are the distribution of answers follows they're equally likely, even though these observed values are not that way. HO says that that's just random chance, and H1 is no, they aren't following the observed the equally likely outcome. So what we do is I've got those in there. Second quit, and then I'm going to do stat, arrow over to tests, and then if you go down, notice I went up. See that chi-square GOF, chi-square goodness of fit. Press enter, and it says where's your observed list, where's your expected, and if they aren't right, you see the blue L1, blue L2, blue L3, etc. You just do second L1, and that'll kick that one back. And if you've got it in L3, you can do second 3, and they'll put the list there. Now we don't. We have it in L2, so I'm going to fix that. And then I've got 4 categories, so my degrees of freedom are 3, is 1 less. And then I'm going to go down and calculate. And there's my chi-square test statistic, and there's my p-value. So WebAssign asks for a t-score. I don't know what the heck. I think he's doing that for a test statistic. It's a chi-square value. Okay. And I don't remember what level of significance he asked us. I don't have that page right here. I suspect it's a 5% level of significance. We'd reject HO. Looks like the test questions are not following the equally likely scenario. Okay, so that's what happens if they're equally likely. And filling out that table out of WebAssign, well, that's a little bit different. And I won't go into that for this video. This was just to show you how to do use the calculator for it. Let me pause this, and I'll come back with a goodness of fit test, a chi-square goodness of fit test that isn't equally likely. So now we've got this one about M&Ms, and they're asking us, does the distribution of colors in a bag of 200 M&Ms follow the established distribution that Mars and Mars, I think Mars and Mars still owns them, follows. Okay, and granted, a bag of 200 it may not, but I mean, 2,000 bags of 200 M&Ms probably would have a, we could have a make some decisions about that. But this is just one sample, and we don't know what's going to happen with it. But so here's what you do for this kind of situation. Again, do stat edit because we're going to edit our lists. I'm going to clear out what I've got in there. And I'm going to type in my observed. So I've got 66, 35, and 44, and 22, 23, then 10. Now we have to follow that established distribution there and all equally likely. So the way I do this to save myself some effort, here, let me press enter. I'm going to go over to L2 and I'm going to type in those percentages as a decimal. I'm going to change it to be a decimal. Remember, move the decimal point over 2 places. Then everything else is 0.1. I'm a peanut M&M fan more than a regular M&M fan. Actually, I just like peanuts, not even the chocolate. But anyways, and they told us there's 200 M&Ms here. If we didn't know that, we'd have to add up those numbers. And there's ways to do this on this calculator. Do I want to go into that with this video? Maybe I can. Let me quit this screen. This is probably worth the time. People aren't as usually up to speed on graphing calculators they used to be. I know my students here at Oxbow are not. I'm going to do stat. Sorry, I'm going to do second list. Talk about not being up to speed. And then I'm going to go to, is it math? Yeah, I'm going to find the sum of L1. So second one. And if you scroll the screen over, we'll see there's 200. Okay, so if they didn't give them to you, you don't have to physically add them up. You can just do it. Well, heck, let's see. Let's maximize this. And then we're going to maximize this. And then we're going to hide this because I don't want anybody's name popping up in this video. Here we go. Clear. So I'm going to do stat edit. And I've typed in those probabilities. Now what I want to do is find 30% of 200, which isn't hard to do, but what if it was a weird number? So what you can do is type in 200 and then do second L2. And what that's going to do is going to take every list, every number in L2 and multiply it by 200. At least it should. It did. So now I've got my observed in L1, my expected in L3. So I'm going to do stat, test, chi-square goodness of fit. Whoop. Here. Gotta go up. Grab it. And then it's L1, and then L3 is where I've got the expected. And then calculate it. Oh, there are 1, 2, 3, 4, 5, 6 categories. So our degrees of freedom is 5. And we're going to blue and calculate. And there's our test statistic. There's our p-value. Large p-value. Data doesn't, we failed to reject HO. The data doesn't support the claim that these M&Ms are not following that's double negatives. It's doing what's expected. Just because they aren't exactly what it is close enough to say it's just due to random variance, random chance. Okay. Hopefully that helps you with your graphing calculator on these chi-square goodness of fit tests. You can do the same thing with a chi-square test for independence. You're just going to enter the data into your matrix, right? You're going to have to edit your matrix and do that. Just a minute here. Let me do that. Let me get a problem where we can do that. Okay, so I've got a two-way table here. I know they gave me the totals, but I don't need the totals for the graphing calculator. What I'm going to do, so I've got I've got two rows, two columns of variables of categories. So I'm going to edit. So let me quit this. Maybe you don't know how to do a matrix. See them over the X to the -1 key, the reciprocal key. Has a blue matrix. We'll do second matrix. Then you got to remember to come over to edit. I've done this many times where I forget to do edit. And this is a 2 rows, 2 columns. And we're going to do the numbers that they gave us, the observed values. And 24, and so I write 27. Yep, that'll mess it up. 24, and then 1182, and 776. Okay, so now I don't have to calculate the expected values. It'll do it. Actually, what it'll do, it'll dump them into matrix B. So let's quit the screen. Let's run a stat test, and you'll see chi-square test. That's a chi-square test for independence or homogeneity, even if you're going to run that. We aren't doing that in this course, but it's the same test. So the observed are in A, it'll dump the expected in B, matrix B, press calculate it, and there's see how that number corresponds to what this person answered? That's right on, the same thing. There's the p-value. We reject HO, or what's the level of significance for this problem? I don't have it. I don't have it. So it looks like the failed to reject ratio must be it has a 10%, and it must be have a 1% level of significance for that p-value, huh? Okay, so that's what you do. Now, just out of curiosity, if you need to fill out a web-assigned table, you do second matrix, come down to matrix 2, just press enter, not edit. Here's our expected values. So that's what you get when you do 1200 times 42 divided by 2000. You get the 25.2, and 1200 times 1958 divided by 2000, you get the 1174 number. Okay, that's how I'm doing it by hand. Okay, hopefully this helps you use a calculator if you have one.